Okay, welcome back everyone. In this video we're going to be talking about plane mirrors and just have a quick introduction to the different types of images that mirrors and lenses can make. So a plane mirror is just a mirror with a flat surface, and when we think about the image formed by a plane mirror, we have to do some ray tracing. So usually what we do is we make an object. Sometimes I'll just draw an arrow, and this is kind of a side view of the mirror. So what we'll do is we will take and trace a couple of rays of light coming out of the tip of the arrow and a couple of rays coming out of the base of the arrow. And what we'll see is that if we follow the law of reflection, then we will form an image. So I'm just going to go in a random direction, and at this point I draw in a normal, and so theta incident will be equal to theta reflected. So these two angles will be the same. Okay? Now the problem is that this ray of light never gets to our eyes, but instead, well, it could get to our eye if our eye was, somewhere up here near the top of the screen. But what we need to do is kind of extend this backwards so we see where this ray seemed to come from. Okay? And we do the same with another random ray. So another incident ray might go like this, and we make another normal, and I'm kind of eyeballing this, so if it's not perfect, sorry. And so I extend this backwards, and what will happen is that these two rays will seem to have come from this point right here. So if this is point A, this would be point A prime. It would be the image of the tip of the arrow. And we could do the same thing with this point right here, but I hope you'll trust me when I say that it ends up right here. So this gives me my image, and this is my object. Now what we do is we define the object distance as the distance between the object and the mirror. And then we define the image distance, di, as the distance from the image to the mirror. And actually, I didn't do that quite even. That's better. Okay? Now, there are a couple of properties of plane mirrors that we should be aware of. First of all, plane mirrors always make what are called virtual images. Okay, so no light rays are actually coming from point A prime. They just look like they are. The actual light rays themselves are striking the mirror and reflecting. But our brain doesn't know the difference. Our brain sees these two rays and thinks that they came from back here at point A prime. So that's one property of a plane mirror. And another picture of it is right here. So this is exactly the same thing. Okay? And so our eye thinks that all the rays came from this point down here, A prime, when really they're bouncing off the mirror. Okay? And notice that these light rays are spreading out or diverging. That's another hint that we have a virtual image. Okay, so there's basically two main things about virtual images. Okay? One is that the images are right side up. So that is a characteristic of a virtual image. And then the other characteristic is that the image distance is negative. Okay? And for a plane mirror, it turns out that the absolute value of the object and image distances are equal. Okay? But if DO was, for example, 8 centimeters, DI would be written as -8 centimeters. Okay? Now, the reason for this, and this is just a convention, is that we say that for mirrors, positive image distances are located on the same side of the mirror. As the object. and the opposite of this is true as well. Okay, so negative image distances are on the opposite side of the mirror. And again, this is the opposite side of the mirror from the object. Okay, now why do we do it like this? Well, it just makes sense that real light rays bounce off of a mirror. And so, as we will see with curved mirrors coming up, if you can form a real image from real light rays that come together after they reflect, then it's going to be on the same side of a mirror. Okay, now plane mirrors, like what you see in the bathroom, well, you're looking in the mirror, right? The image appears behind the mirror. And so for that reason, that is a negative image distance. And so we can prove this, that we have the same magnitude with similar triangles. But I'm not going to go into that right now. Okay, so the last thing that we're going to talk about is the magnification of an image. So we need to know whether or not a mirror or lens is making the image larger or smaller. And it turns out that for a plane mirror, the magnification is simply equal to 1. Okay, it doesn't make the image any larger or smaller. And so there's two definitions of magnification. So it's a capital M, and it is defined as the image height divided by the object height, or it is the negative of the image distance divided by the object distance. And so this will make sense because, first of all, if magnification is positive, that means that the image is upright, or right side up. If the magnification is negative, then we're talking about upside down or inverted. And for a plane mirror, remember that we have an object and a mirror and an image. Well, they are the same size, so it has a value of 1, and they're upright, so it's positive 1. Okay, so if I were to measure the object height, okay, versus the image height, I would get the same thing. And then let's just go with my example of 8 centimeters and negative 8 centimeters. Well, positive 1, is equal to the opposite of negative 8 centimeters divided by 8 centimeters. Okay, so that's how we define magnification. So plane mirrors are fairly easy to work with. The tricky part is when we start making curved mirrors, and that will come later.